Hi, it's excellent to be here. I want to share with you today a transformation that's happening among economies and organizations around the world, and I'm very excited about it. I think it's going to change the way you're looking at the world and the way I think about things. So let's go with my slides, which I'm hoping that you see someplace. There they are. So if we think about Zipcar, the reason I knew it was going to succeed is because of three things. The first was that we were leveraging excess capacity. And what would be that excess capacity? The way you could buy cars before was forcing you to buy much more car than you wanted. So for example, for me to own and operate my own car, it's $9,000 a year per person. None of you probably believe that number. That's the real US household survey number. That's actually what it costs, about $25 a day. And that means that if you don't need a car to get to work, day in and day out, for 5 days a week, $125 is just like slipped you by this incredible excess capacity. In fact, people only drive their cars about 5% of the time, and it's the second most expensive asset that they own. So there's a lot of embedded economic excess capacity in there. Your other choice was to rent a car, and when you rent a car, you had to buy it in these 24-hour bundles. Again, I want a car for 2 hours or 26 hours, but the rental industry was forcing me into these 24-hour bundles. So I knew, because we were leveraging excess capacity, that there's a lot of economic slack in the system. That would be reason one why we would succeed. The second thing that we did is we built a platform for participation. And by that, I mean, if you're going to rent a car for an hour, we had to make it really simple and really easy for that to happen. And we gave to individuals a whole bunch of things that that car rental companies used to do. So we made it really, really simple, bundled as you guys know, you can rent it just for an hour or for a day. The insurance is included, the fuel is included, made it really, really simple. And this platform for participation is what made it happen. And the third piece is that we treated our members as collaborators. Going back to this car rental model, in the car rental industry, it's you across the counter from the car rental guys, and you know that they're screwing you on price, and they're thinking that you're going to ruin the car, right? There's this really oppositional piece. And for Zipcar, we said, you know what? Not only are you not on the other side of the counter, there are no counters. You're on our side. We're all in this together. And we gave individuals tasks and responsibilities that used to be what the company would do. For example, walking around the car and making sure that it was damaged or not damaged, filling up the car with our fuel card when it went to a quarter tank, telling us where the best parking spaces would be, or telling their friends about it. These were all things that used to be on the company's side, and we gave to you. And so we really thought of our consumers as our co-creators, and I always talked about them as our members. And if we think about where we are in the world today, I found this comment. This was back in 2000, and here we are 2014, and here's Moses coming down out of the mountain, and he says, is there a section on the bottom for comments? Absolutely. Even with God, we are thinking that we are co-creators, right? There's no more sitting back just thinking that you're passive consumers. And even as I think about that word consumers, doesn't it sound kind of 1950s? Like, there you are, you consumers sitting there. We are really all co-creators, and we're expecting to be participants now. So if I put these three things together, excess capacity, people, and platforms, this is the infrastructure that is really driving all of the cool things that are happening in our world. And I call this new collaboration Peers, Inc. And it's people and platforms that are inventing this new collaborative economy and really reinventing what it means, what capitalism is and means. And this is something you guys should all recognize. So all of these companies that we've been talking about for the last decade, they really are, underpinning them is this type of structure. So, eBay, it's based on, my stuff, and Linux, it's my code. With YouTube, it's my videos. Skype is just kind of a remarkable idea that we built a telecommunication company on the back of my laptop, my video camera, and my internet connection. Like, no fiber cables were used in building this amazing thing. So I want to give you some examples of what the implications of this new kind of structure are. Whenever we're leveraging excess capacity, you can think about this as sharing, because this is an asset that you no longer own and control in your own self. When we talk about excess capacity, it is necessarily a sharing activity. And so my favorite example is bed sharing. And so get in your minds Bed sharing, you guys got that down? Bed sharing? I do a lot of travel, and when I go to new places, I like to stay at friends' houses, and I like to stay in their excess spare bedrooms, because they might have had a kid who lived there, or it might be doubling as their office, and so I would be staying in people's houses, and if I'm really lucky, I get a double bed excess capacity, and it's fabulous, and if I'm really unlucky, I get stuck in the 16-year-old's room with the dirty sheets. Ick, I really don't want to be there. And in fact, that's why hotels were invented, right? Hotels are really bed sharing. And when I when I founded Zipcar, I kept telling my staff, stop calling this car sharing. A, no one knows what car sharing actually means. You're still going to have to explain it. And imagine if we called hotels bed sharing, how differently you would feel about lying down in that little, how many people's head have hit that pillow? But it's the exact same principle that, Zipcar is to cars as hotels are to bed sharing. So I went and did some research, and what did I learn? The largest hotel in the world is the Intercontinental Hotel Group. In 65 years, they built 645,000 rooms, 4,400 hotels in 100 countries. That was a lot of work, right? It was a lot of work, and the second largest, the Hilton Hotels, has been around for 93 years and hasn't pulled this off. And lots of you, being we're in San Francisco, will know what my next slide is. Airbnb, in its 4th year, had as many rooms for rent as the largest hotel chain in the world. And this is where I do my, can you believe it? Wow, incredible, the world has changed. This is really transforming everything. Couchsurfing, in its 9th year, had 2.5 million rooms that you could stay in. Different principles, but still the same idea of leveraging excess capacity. Why is this going on? Like, what in heck is happening? If we look at why did we ever invent organizations and governments, it was to do things that we as individuals couldn't do. That's why you invent these bigger structures. And what kind of strengths do they have? If we think of industrial strengths, big companies can do things I can't do. They can make really large investments. They do things that take many years. They do things that require different kinds of intelligence, kind of aggregated. I'm smart in maybe 1 or 2 things, but it takes a big group of people to do things that require lots and lots of different types of expertise integrated. If you want to talk about standards or consistency, Robin Chase, or any individual have a really impossible time trying to force people to accept my standards. Like, you don't care what Robin Chase thinks. What you really care is like some big brother is telling you what to do. And typically all of this is kind of bound together in a brand promise, and these companies are global. So those are fundamentally things that big companies and big entities do that small people cannot, and that's why we invented them. On the other hand, individuals have things that companies used to do before the internet, but they hated doing them. So I would think of these things as anything has lots of small parts. The Industrial Revolution was to make everything standardized and big. They hated dealing with small parts. Customization, specialization, localization, definitely didn't want to do it. Very expensive. Yeah, we'll do it if we have to, but we hate doing it. Think about tapping into my social networks. All the companies want to tap into my social networks, but I naturally am always talking to my social networks. And things that required a lot of creativity and are local, these are things that individuals do really, really well. What the internet did is it took away the cost, the transaction costs, and the efforts of playing with these small parts. And so we can now put these 2 things together, and you'll see that they're really, really complementary. And it's this complementary new symbiosis that I'm calling Peers, Inc. And it's this new organizational structure where each side does what it does best and leaves the other stuff to the other people. So the Inc. side will create the platform for participation, and the peers will deliver this diversity of offering. And I'll tell you a little bit more about this. And to make it kind of simplify it, I see it as a yin-yang. They're very complementary and symbiotic. Each side will only play if they're getting enough value. So it's a push and pull of value, because you as a peer won't do it if the platform is taking too much. And as a platform, if the peers aren't going to leave anything on the table, why bother? I'm not going to build it. And it's all kind of swimming in this sea of excess capacity. And how am I defining excess capacity? It's very resource and cost efficient. And I think of it as excess capacity as things that already exist, have already been paid for, and there's more value to be extracted. And as an entrepreneur, I'm constantly looking at excess capacity because it transforms the economics. Someone else has already paid for it, and now I can get it at a much, much lower cost. So there's 3 ways to tap into excess capacity. One is to slice it, and I'd say that's what Zipcar did. It took this big, big bundles, and it sliced, it offered up in little tiny pieces so that you could get into that excess capacity. The second way you can do it is aggregate. You can think about Airbnb as an aggregation. You know, Airbnb is not like 650,000 bed and breakfasts. That's really hard and irritating to get to compare and contrast and to deal with, but on the Airbnb platform, it's now nicely organized. They aggregated all those small parts. And the third way is to open up this asset. And you can think of the open data as an example of that. There's new value. We don't even know what you're going to do on it. We've opened it up. And I think the best example for this would be the smartphone. So the smartphone would be the platform for participation, and you can think of all the different types of apps that have now been built on top of this that didn't require knowing about embedded systems, much more tricky engineering, and a much higher economic cost. All of those apps are just playing on top of, you can think of useless apps versus clever apps. Think of all the useless apps that you would never pay for a $600 phone to use. But because you've already paid for that phone, all of these apps, you can start adding them on because the excess capacity is there. Looking back at my chart, if we think about the incorporated side, what does that deliver? When you make a platform, the sheer platformness delivers economies of scale. We can tap into these things that used to be the only available to big companies. And these things enable really high growth. When I think of this Peers Inc., you can think about the platform giving to the people the powers of the corporation that we never really appreciated before. So again, looking at this high growth model, you can think about these platforms, and in the last 5 years since smartphones existed, we have seen over 2 million apps have been created on top of this, on these platforms. It's like this phenomenal amount of innovation that is happening. The last piece is under peers and the diversity of peers. They're delivering innovation, resilience, and redundancy because there's so many of them. And an example would be my company in France, which is peer-to-peer car sharing. And these are pictures of owners in front of their cars. And you can see that it's all different kinds of owners in different locations with different price points. That's the south of France. You can see all different kinds of drivers, very cool owners and very uncool owners. The necessary hipsters. And what Buzzcar can deliver is cars everywhere at different price points, whereas Zipcar can't play in every single geography because we couldn't get a return on investment. So again, Buzzcar is leveraging excess capacity even more so. So the question is, why do I care about this Peers Inc. and what is it doing for us? Why do I care is because I think this is going to play into how we address climate change. And this report was produced by the World Bank, a very conservative financial institution. And the 4 degrees Celsius is where the world will be by 2100 if every country does every single thing it has said it was going to do. And you say to yourself, what is 4 degrees Celsius, 7 degrees Fahrenheit actually mean? Like, what does it mean to me to have global average warming of that? So I went and did some research, and I found out that the last time it was minus 7 degrees Fahrenheit, minus 4 Celsius, was in the last ice age, which was 15 million years ago. And not where I'm standing here, but if I were in Chicago or in Boston, I would be under a kilometer of ice. So the difference between minus 7 degrees and today was 1 kilometer of ice, and we're going forward that amount in 85 years. So this transition is happening in an incredible speed, and there were no humans 15 million years ago. But it gets a little worse, because what I realized when I went and looked at this report is that plus 7 Fahrenheit is what it means globally. But over land, it's going to be plus 11 degrees Fahrenheit in North America in the summertime. And that is by 2100, if we do everything we promised to do. And if we don't do things that we promise to do, we're going to be seeing that by the 2060s. Terrifying. And then just to make you feel even worse, this is to get this 2-degree goal that we keep talking about. So the difference between 2 degrees and 7 degrees is the difference between driving on an icy road at 30 miles per hour versus 90 miles per hour. It's risky at 30, but deadly at 90. And this is a quote from this scientist when the last report was released. So we are right now driving towards the risky, still bad things will happen, and hoping crumbly that we're going to avoid the 90, but we're actually going straight towards the 90. Right now, that's where we're going. So when people talk about, let's do this for our grandchildren, or let's do this for whoever, I think, what are you kidding? If by 2060 it's going to be plus 11 degrees, by 2040 it's going to be pretty darn unpleasant. We are talking right now. And I'm looking at my time, and I've got to go very fast because the best is yet to come. So why have I been dealing with this? A friend of mine at Stanford said, you can't solve exponential problems with linear solutions. And indeed, this is an exponential problem, and we have been addressing it with linear solutions, which is why I'm saying try Peers Incorporated. There are these 3 miracles that this type of structure can give you. And so miracle number 1 is we can defy the laws of physics. So if I had said to you in 2000, I, Robin Chase, am going to build the largest hotel chain in the world, and I'm going to do it in 4 years, everyone in this room would have said, that is physically impossible, Robin. No way. You can't build those hotels and get the land, hire the architects, do the financing, build the stuff, fill it with people. We would all have said, absolutely impossible, Robin. And this is what building business as usual would look like if I started today and I went forward 6 years. And this is what Airbnb's assets of rooms available look like. That is phenomenal. We have to leverage excess capacity if we want to move really quickly. And Airbnb didn't just produce the assets, it produced the actual people using it. And here is BlaBlaCar, which is real ride sharing, as in I want to go from Paris to Lyon. And I have my 3 empty seats in my car. You can see that they are now transporting 10 million people a month. No, 1 million people a month. They have 10 million members, which is the same as 2,500 high-speed trains or 2,500 747s. They didn't lay a track. They didn't buy a rail car. This is the speed and pace at which we need to work. Here is Waze. I'm looking at my time. Waze today has 50 million people that are using it. Let me just go past that. Topcoder, Etsy, all of these companies. Miracle number 2, we can tap exponential learning. The way that you measure learning a language is how much can you learn in 1 semester of a language. And that is 130 hours of instruction. Rosetta Stone used to be the fanciest one that diplomats and businessmen would buy and pay a lot of money. And Rosetta Stone would say, hey, yeah, we can do this in 54 hours. And we all would say, wow, that's so much better than 130. But Duolingo came along, and Duolingo offers free online language instruction. And Duolingo, their CEO, told me he can conduct 100 experiments simultaneously with 150,000 people, iterating on each one of those, and in 48 hours he can tell you precisely what is the real way to better learn a language. And so he has got it down to 34 hours on average to teach you a semester's level of a college instruction. It is phenomenal because you think of learning has to do with a number of iterations, and we can now get a lot of iterations out. And here's Duolingo's growth. 50 million people in less than 2 years are using that app. And it's online as well. Oh my God, I've got to get to this. Miracle number 3, the right person will appear. And no, it is not Superman. If you guys think about Superman, we right now are so much better than Superman. So there's something terrible happening across town. Superman does not know the best path, right? He doesn't know what's telling him where it's congested or not, and he doesn't even know what's happening exactly there. They're just saying something bad's happening. So using something like Waze, you can be driving along. I've been already told the best path to get there, and this happened to me last Thanksgiving. This isn't my car, but this isn't my picture, but this actually happened right in front of me. The car accident actually happened, and the 2 cars are hitting each other and sliding off the snowy street because we had a foot of snow on Thanksgiving Eve just now. And within seconds off of the Waze app, it said, caution, car accident ahead. And I thought, who is there sitting between me and the car? It was clearly the guy in the next lane who was putting in car accident ahead. So the right person will appear. That when you have so many people iterating on these platforms, there is the right person with the right expertise locally. Your front-running sensor is right there. So it's a real collaboration. let me just put these things out. It's because we're leveraging excess capacity that we can defy the laws of physics. It's because we're using a platform that can see and analyze and aggregate that data that we can have this exponential learning. And it's because diverse peers are participating that you can have the right person at the right time. It's really critical for us to understand that's why this structure works. These three components are necessary. So I believe we are positively moving from the old industrial economy to the new sharing economy. And it is absolutely happening, and I'm going to tell you the 4 reasons why I think it's happening. These are truisms, and you guys can look at these, and during the Q&A, if you see anything that is not positively true, please feel free to bring it up, because these are completely true to me. Number 1, shared networked assets deliver way more value than closed proprietary assets. And remember, they deliver it 2 ways. One, they use the asset more efficiently. The second way, when you open something up in its networked, is that people can think of new values that you never even thought of. So necessarily, positively, shared networked assets are more value than closed assets. More networked minds are way smarter than a few walled-in minds. So Bill Joyce said this famously, that no matter how many brilliant people there are in this room, there are way more brilliant people outside of this room. Fact, like you can't say anything about it. And when they're networked, we can touch them. Number 3, the benefits of open shared resources are way larger than the problems of open shared resources. So think about spam versus email. Think about people scribbling on Wikipedia entries versus having the world's encyclopedia online. Benefits of openness way outweigh problems of openness. And then these 3 are kind of big general for big aggregates of people. But if I look at just me, Robin Chase, when I participate in a shared networked asset, I get way more than I give. So I write one Wikipedia article and I have an entire encyclopedia. I pay my taxes and I get an entire library of books and I get national defense. And spying. But these things are fundamental, and they are so true, everything is going to be going to this platformized way. And I'm going to stop there and let Wendy speak. Thank you.
Thank you, Wendy. This is videotaped, so there's a lot of great information. I was trying to tweet. It was hard to keep up. Next, we're going to have Wendy Schmidt come up to the stage.
Good afternoon, everybody. I'm going to take this down. Might drink some of it, but shouldn't be using our plastic water bottles up here. Thank you, Robin. That was really, really interesting. And Carol, for inviting me to be here today. It's an honor to be here to speak with you this afternoon. Before I begin my remarks, though, I do have a confession to make. In 2nd grade, when I was 7 years old, I was thrown out of science class. It's true. Now, the reason, well, let's just go back there. There were 22 of us in the classroom that afternoon, and we were in our rows of desks with our little plaid, tidy Catholic school uniforms on. We were instructed by our young teacher, a Miss Holsworth, to take out our books for science. She taught us all our subjects. It's time for science. So I lifted up the front of my desk, the lid there. I was in the 3rd row, I think, and I looked next to me to my neighbor, John Sullivan, in the next row, and I turned to him and I said, "I hate science." Well, Miss Holsworth didn't miss a beat, and she called me out in front of the entire class to stop the virus that was me from spreading in that classroom, and told me, "You are going to the kindergarten." Well, going to the kindergarten was a punishment just one level underneath full afternoon detention. To be sent from the classroom in a walk of shame down to that red linoleum classroom that was filled in the morning with little kids on painted wooden chairs, and to sit there by myself all afternoon to contemplate my miscalculation. So what was it I was reacting to? I wonder that now. How does a child hate science? And where was the disconnect for a child who was otherwise interested in learning and creative and imaginative? Well, why didn't I think science or the space race or Jacques Cousteau's wonderful world under the sea had anything to do with me in suburban New Jersey? It was also disconnected. Surely you remember the caricature of the mad scientist in the 1960s? These were the guys who built the atomic bomb, and there we were, little children growing up in the Cold War, contemplating our future living in bomb shelters. Science. For a lot of us, excepting the more technically gifted who were already sporting those glasses with the tape, science was really just not that engaging, unless you were lucky enough to get one of those science kits that you used to get at the holidays, and then there was always the chance that something might blow up in your basement. Today, I think science is about as important a kind of knowledge as we humans can have. Not only is it about discovery and wonder and our place in the universe, about systems, it may very well be about our survival, as Robin was saying. From now on, basic scientific literacy is important as knowing how to read at all. It's so basic that I would argue you cannot understand the complex world we all share without any accuracy, without a scientific perspective. And here's my trope. It would be like living your life in a rich cultural community that spoke a language where you could never decipher a single word. Without the lens of science, without having some idea how the technological things we use actually work, we're in danger of compounding mistakes we've been making at an alarming rate since industrialization began. Most people flick a light switch without a clue where the electricity is coming from, and this ignorance is hardly bliss when you witness mountaintop removal or coal mining for local consequences of fracking on groundwater, animal and human health. By the way, you might have seen this picture before, but this is all the fresh water that there is in the world. We live in a time of unprecedented and rapid transformation in the way we use information, energy, natural resources, even excess capacity, and in the way the human population has grown large enough to have a dangerous impact on the living systems of the planet, filling our oceans, even the Great Lakes, with plastic, 1.1 million particles of microplastic per square mile in a study just last year. The oceans are under attack by runoff of fertilizer from agriculture inland and upstream, by crude oil spills, by overfishing, as we pump fossil fuels from the ground, contaminating groundwater and filling the atmosphere and oceans with excess CO2 and methane. The effect of our massive technology is that we're changing the chemistry of the planet. And so we need to think very carefully before embarking on any large-scale, uncontrolled experiments to geoengineer our way out of this. Let's not work at beating nature, but at understanding nature's systems and working with them. Everything we do at scale is impacting our fellow inhabitants of the Earth, large and small, known and unknown. In fact, the human effect we collectively produce is far out of scale for the biomass we actually represent here, isn't it? We are far exceeded in biomass by ants and by the tiny Antarctic krill. They're very cute, but even they're at risk now from warming, acidifying ocean waters and habitat loss. Thinking about the human footprint brings to mind a kind of mischievous image conjured by the father of naturalism, the coiner of the word biodiversity, E.O. Wilson. In his book, The Creation, an appeal to save life on Earth, published in 2006, he wrote, "It is mathematically possible to log stack all the people on the Earth into a single block of 1 cubic mile and then to lower them out of sight into a remote part of the Grand Canyon." Today, as Robin was recognizing, everything is a question of scale and impact. My mother often complains to me that the world today has too many people in it. And there are. Compared to the world she entered in 1931 with its 2 billion inhabitants, we've reached 7 billion humans today with projections of nearly 10 billion by mid-century. But there's another kind of scaling that's been going on since I was in graduate school in the early 1980s, when computers were still the size of this building and when the consumer market for computing technology didn't exist. The first portable phones looked like this in 1973, and we use devices called mobile phones today for so many other things. They're way beyond telephone technology. The complex computing going on in our devices happens without our even knowing it. All we know is that we're getting on with business. You're texting out there and tweeting and blogging and searching and shopping and sharing pictures and cyber stalking some of you. You know who you are. Computer and communications technology and all the networks that they have created have changed the way we do almost everything and have opened people up across the generations and across the nations of the world to absorb information as never before possible, to experience living in a network which mirrors the natural world, to see and hear data in most places with connectivity from anywhere in the world, often in real time. These extremely rapid advances since the first microprocessors showed up commercially in the early 70s have also created unprecedented opportunity for the scientists of this century to engage the public in new and transformative ways. From the way science is taught and learned, think of Khan Academy lessons, to the way science practitioners engage in the work they do, alone and in newly possible collaborations, to the way that scientists can engage new audiences in demonstrating the richness of the living world we share by seeing it through different lenses, from the very large to the very small. I came across this marvelous bit on Facebook a few weeks ago on BuzzFeed, and it really put things in perspective. And we can go through these pictures kind of quickly, but I think they're really fun to kind of look at. Let's start here. This is where we live. Okay, we're in our solar system, as you know. There's a distance there between the Earth and the Moon, but that's what you could fill it with. That's pretty interesting. Okay, and then there we are. That's North America on Jupiter. And here's the size of 6 Earths compared to Saturn. Okay, it's big. And this is kind of cool. We could have rings on Earth if we were Saturn. That's kind of neat. Remember this one? We landed on an asteroid. That's how big it is. There's Los Angeles. And then we've got our sun, and I think you can see that tiny little dot. That's Earth. And here we are from the Moon, from Mars. Yep, you can kind of see us behind Saturn's rings. Yeah, farther out. There we are compared to the size of our sun. That is pretty terrifying. And the sun from the surface of Mars. Carl Sagan talked about the grains of sand and all the stars that we can see. There's a sun much bigger than ours. There we are in the Milky Way. That's all you ever see, that little dot. And of course, we're a runt compared to others. All those thousands of stars, all those galaxies, and all the night sky you'll ever see. There's a big black hole, and there's the orbits of Neptune and Earth. Anyway, I show you that because I think the real challenge for today's scientific community is to find ways like this to use visual communications and networking tools to engage the public in a much deeper understanding of what the data means. This calls for new models, it invites new collaborations across traditional disciplines and across the world, and it engages private philanthropy in new ways too. And it is happening. I feel like our work in funding science is part of this giant wave. It's unfortunately the case in the US that federal funding for basic science has dropped precipitously since 2010, from a high of $40 billion a year to around $30 billion, and that impact has been felt throughout most every lab, project, and research center. The good news, and yes, it is only a drop in the bucket, relatively speaking, is the commitment of about $125 billion over the next 5 years by private investment. This is according to a study done by the New York Times last year. Private philanthropy in science is nothing new, but it has taken on new and strategically important role, I think, in making sure the frontiers of transformational discovery remain open, especially when we hope ultimately to reduce the negative impact of the human activity on the interconnected living systems here on our planet. Now, I first got involved with the X Prize Foundation, as you heard, in 2010 when the Deepwater Horizon oil tsunami was spilling into the Gulf of Mexico. It was creating a surface oil slick the size of the big island of Hawaii, disrupting living systems and the economy of 5 Gulf states for generations. Our oil spill cleanup competition produced something very tangible, a market evolution in the science of surface oil spill recovery. 4 of the 10 finalist teams achieved in 4 months what the industry had not done in 20 years because its own incentives for improvement were lacking. Last year, early in the year, we convened a meeting in Washington of an advisory committee of some 30 scientists who spent a day helping us design the goals of the latest Ocean Health X Prize. It ended up becoming 2 prizes instead of 1 for 2 very different kinds of devices that will measure ocean acidification at different levels of accuracy for different applications and at different price points. 18 teams are now entering the second phase of this competition, and the whole thing should wrap up before summer of 2015. The X Prize looks for breakthroughs. Let me see, we're going backwards here. Guys, you're ahead of me on these slides. X Prize looks for breakthroughs in science and technology and brings philanthropic funding to contests that convene teams that, even if they are not themselves scientists, rely on science and scientific advisors to bring their ideas into testable designs. This is a great role for scientists. My husband, Eric, and I have directed funding to other strategically important science research projects, among them the Scripps CO2 group, and that's why this slide is up there, maintains the Keeling curve. Professor Ralph Keeling, working in San Diego, can now restore the atmospheric measurements that had actually been discontinued due to lack of funding, and address a 3-year backlog of samples that have been collected but not analyzed. The Keeling curve measurements began at the flagship Mauna Loa Observatory in Hawaii, but are now gathered elsewhere as well, from Alaska to Antarctica. The value of the Keeling curve has increased since measurements began in 1958, making discoveries about Earth's processes possible that would have been extremely difficult to observe over short time periods or with only sporadic measurements. I have some colleagues here today at this meeting from Climate Central, an organization based in Princeton that I helped to establish in 2008 with Steve Pacala and Michael Oppenheimer and Jane Lubchenco, John Holdren, Heidi Cullen, and Ben Strauss, to bring together scientists who study climate change, social scientists who study human behavior and systems, and journalists and digital media professionals to communicate what science is telling us about climate change, not as advocates for any particular policy or technology, but just as honest brokers of information for the public, for industry, educators, city planners, insurance companies, NGOs, public safety officials, policymakers, you name it. To enable them, for example, to model a variety of scenarios of sea level rise in local geographies, or the increased local risk for certain types of extreme weather events. Last year, Climate Central launched a program called Climate Minutes. This is an example of one of some of the content. They provide weekly packages of local and regional climate data and TV quality graphics to weathercasters around the United States. These are those television personalities whose audiences remain among the largest and most loyal in broadcasting. Here you can see a couple of them with the content. The Climate Central content is embedded in the weekly forecasts of more than 200 meteorologists now, 35 of them Spanish-speaking, in 85 different markets. We survey the impact to make sure we're having it and find climate science is reaching new audiences. At the Schmidt Ocean Institute, we've taken the historic brick and mortar idea and turned it into a mobile institute, one that lives, if you will, aboard the research vessel Falkor, launched in Hamburg, Germany in the spring of 2012. Falkor was a distressed asset of the German government when we purchased her in 2009, a retired fisheries protection vessel. We salvaged her steel hull, rebuilt the rest of her to create a state-of-the-art research vessel designed to host research teams from all over the world of up to 18 people, sharing the ship's cloud computing systems, its high-frequency multi-beam sonar that creates high-quality bathymetric mapping, and the ship's deep ocean robotic vessels, equipped to gather samples, carry high-resolution cameras, and even provide streaming video during missions that can be seen on the SOI website and on YouTube. New upgrades to the ship's satellite's internet system enables Falkor to send its remotely operated vehicle or other video signals directly to shore-based encoders that will process the video and forward it to YouTube for live broadcasts, chopping the previous broadcast delay in half. Since her launch in the spring of 2012, Falkor and her crew of 22 have traveled a distance greater than twice the circumference of the Earth. She's mapped in detail an area of the ocean twice the size of Greece, chipping away in an effort to expand high-resolution ocean floor mapping beyond the 5% that had been mapped before 2012. To date, Falkor has completed 18 science missions and hosted scientists from 46 institutions with groups from 12 different countries. In exchange for ship time for this far-flung community of researchers, SOI requires visiting science teams to share the raw data they collect in their research aboard Falkor in a proactive and systematic way. We believe, given the challenges to ocean health from industrial pollution, overfishing, climate change, and acidification of the ocean, we are in a critical time for understanding ocean systems and for filling in as fast as we can the details of what makes up our inner space, so that it can no longer be said that we know more about the backside of the moon than we do about the bottom of the ocean. Late this past spring, Falkor took 2 month-long mapping expeditions out of Honolulu to the Papahānaumokuākea Monument, bringing back images of the ocean floor data from an area almost 7 times the size of the main Hawaiian Islands. To give you an idea of scale, the monument stretches over a distance you'd travel from Las Vegas to New Orleans and is larger than all the United States national parks combined. Falkor created new detailed maps, discovered new species, and a surprisingly elaborate biodiversity around the monument, which extends deeper than anyone knew and also contains ancient Cretaceous seamounts mixed in with the newer Hawaiian mounts, raising curious questions about Hawaiian geological history. All this, as well as the research from our first student crews aboard from the University of Hawaii, are publicly available on the SOI website. This fall, Falkor has been traveling from Guam with scientists aboard mapping the mysterious Ontong Java Plateau north of the Solomon Islands, an area larger than Alaska, and traveling to study life in the Marianas Trench, in the deepest part of the ocean. How deep is it? One crew member aboard Falkor put it this way: to reach the bottom of the Marianas Trench, you need 42,976 pieces of packaged spaghetti. The pressures at that depth, as another crew member put it, are like 50 elephants standing on your head. So this is some footage I'm going to show you that came from one of our landers designed to go down to the bottom of the trench and to return to the ship with samples of rock and mud and creatures. As you watch some of this footage, I'd like to share a few lines from a blog posted by Dr. Patricia Fryer, a marine geologist from the University of Hawaii, who spent time aboard the ship and retrieved some samples. Life on this planet is wildly diverse, she wrote. The relationships between living things and extreme environments are myriad, from ballooning spiders in the jet stream to microbes burying into the subsea floor rocks. Our greatest research tool, curiosity, leads us continually to finding out greater and greater interrelatedness of processes geological, chemical, physical, and biological. Everywhere we look, every time we descend into the ocean's depths, we see something nobody else has ever seen before. Every time. It staggers the mind to realize how much more there is to be learned. It's what drives our lives and fuels our love of research. Our work is our hobby, but it's also our job to share what we learn with the world. The outreach effort is a great thing about the SOI mission. One of the undergrads on this cruise had never heard the word amphipod before, never held a supergiant. And now when you mention it, her eyes light up and her excitement is totally infectious. That is what it's all about, sharing the passion. Which brings me to my conclusion, to share what my 9-year-old grandson told me a few weeks ago after he let me know that he'd be getting a PhD at Harvard in microbiology. Oh, I said, and why Harvard? He said, well, they have the best graduate program in microbiology. I said, why microbiology? Why that in particular? He said, well, because, you know, the biggest creatures get all the press, but it's the smallest creatures that are the most interesting. And I said, okay, go on. Nana, do you know what the strongest creature in the whole world is? It's not visible to the naked eye, but it can live anywhere on Earth in places as cold as negative 273 degrees Celsius and a heat as high as 125 degrees Celsius. It can live in no oxygen environments like space and in the pressures of the deep ocean. It can adapt to every kind of extreme condition using a kind of super hibernation, reducing the water in its body to 0.01%. Okay, I'm intrigued. Do you know what will survive a nuclear explosion, he asked, patiently waiting for me to figure it out. Twinkies, I said, duh, and tardigrades, he said. They're also known as water bears or moss piglets. They're segmented microanimals with 8 legs, and they were discovered in 1773. Where is he getting all this information? Well, first, he likes to read a lot. Like most boys his age, he likes cool and gross and extreme stuff, but he's also connected online to sites like Animalist News. This is a site that captures the awesome, the bizarre, and the adorable, a daily video fix on the animal kingdom. This is his entertainment and his education. When I was a child, a microbiologist and an astrophysicist might not walk paths that ever crossed. But today, when water bears are finding their legs in space and teaching us all something about the nature of microscopic life, and when creatures are living in methane vents and in the deep depths where the pressure is like holding up 50 jumbo jets on your head, it all suggests to me we ain't seen nothing yet. And it's all connected. The silos of specialization are giving way to the power of science seen as a whole. We have a lot to talk about, a lot to share, not just within the scientific community, but with people who are making decisions about how we will preserve the resources of the Earth that we depend on for our survival. Remember that Grand Canyon. And with people like my grandson. I don't know if he'll make it to Harvard. I don't know if he'll be a scientist, but I do know science doesn't scare him, and no one will ever feel the need to punish him for lack of interest. He's already hooked. He's listening, and those little creatures had him at hello. Thank you very much.
Well, thank you, Robin and Wendy. I want to say that this was so much to take in. I mean, this whole difference in how we think about our science, the impact, who's accessing it, how do we get funding in this networked world, how do we combine our resources that we have with someone else to make a project go is very exciting. So we'd like to open things up for some questions. We have microphones, and you can ask some questions, and it may be that Wendy, it may generate some discussion between Wendy and Robin. So questions from the audience? Or we have an online audience as well. Does anyone have any questions?
There's one way over to the left.
Okay, sorry. It's hard for me to see. Go ahead, please. There's a microphone.
The two talks were very inspirational, and I was wondering if you could talk between yourselves perhaps on leveraging the technologies that were in Zipcar that were looking at, let's say, market forces, not so much as saving ecosystems explicitly. In the second talk, which was focused on the idea of restoring and protecting our ecosystems, is there a way to use the market forces of the first speaker to incentivize more protection of ecosystem services?
That's a really interesting question that I haven't thought about before. Just as I was listening to Wendy, I was struck. So I was struck by, if we think of the ship, I would think of that as a platform for participation that is enabling, all of that equipment is now being, I would imagine, more efficiently used, and the data, given that it's open data, is being viewed by more eyeballs. So if we go, and I would project that that's going to generate more innovation and more creativity and getting more value out of those things. Then to your piece around the market, what that type of environment has enabled is, one would expect, is a much lower cost of innovation and new thing discovery. So I just keep coming back to this structure as the one where we're going to use resources most efficiently, and resources being money, people, and assets. So if there are market connections, this would be the way the market would go after it, because it would be so much cheaper and more efficient to do it. But I'm afraid to go down that path, just because isn't that one of the nice things about research, and one of the terrible things is that it doesn't know where it's going sometimes. So you guys are out there, you're probably saying, Robin, you're completely wrong. Yeah, I had my hypothesis and whatever. But ultimately, you don't know where that is going to end up. And I think that's how you uncover a lot of fascinating stuff. And that's one of the things we have to enable, is this ability for people to experiment.
This is on, okay. Just to add to that, one of the motivations that we had in setting up the Ocean Institute the way we did was to accelerate the pace of scientific research, exactly what you're saying, to bring things forward by sharing the data, by creating more eyeballs on the data, and more opportunities for innovation.
So just think, the cost per anything you find will be lower using this structure than any other structure. You guys, we floored you with our brilliance, no questions.
I have some questions. One is, there's two questions. One is, one of the aspects of science that's so important is the ability to do deep thought that takes a while. Right? So we have this fast-paced world, all of these abilities connect things and put things together, which we're all used to putting together projects. We now have disparate sources of, trying to think the sharing economy or private philanthropy and putting together a project, but then it still takes time. How do we fit that slow, deliberative process into this whole need to connect things quickly?
I've been thinking, so if I went to an economic model, and we were discussing this over lunch, so it does feel to me like it is, of course, the place ripe for government. And the larger the economic unit, that's why we have the luxury of guys like you who can do deep thinking for years and years at a time. And I just was struck when I was visiting MIT and their neurobiology. I thought, wow, how incredible that we can have people who day in, day out do these small things because our economy is big enough that we can support that. And that's the crisis, is as the government decides that there's going to be fewer dollars attributed to that. That's what you guys should be worried about, which is why democracy is something to care about.
I would just point again at the opportunities for new kinds of collaborations, right, across disciplines, across countries. There are places that are very well funded right now in basic research, and we need to create those partnerships and opportunities for people to, yes, do the long-term science, which is underlying everything else, and to take advantage of the opportunities that otherwise just sit there on the shelf.
And I am wondering, and I don't know in the science community, how much open data is there out there that's been arranged and organized for you to do this? And I know E.O. Wilson had his project, which I felt was, the catalog of living things. But all of those, so are there platforms in the science community that enable people to put their assets and their discoveries, their data online, so you don't have to keep repeating? I was just reading about, in the pharmaceutical industry, GlaxoSmithKline, which is now just called GKS, whatever, they are now doing more research that is collaborative research with the data being put online for orphan drugs and things where they can't make a lot of money. So it's a way of pooling these resources and pooling the research and the data. It keeps coming back to me that this ability to collaborate and have more resources pulled together so that you can get more value without having to keep pouring in.
Thanks. Jim?
Yeah, sticking with this theme of funding sources, we're talking about that a lot in AGU these days. Corporate funding, private foundation funding, crowdsourcing. And thank you very much for your extreme generosity. I mean, the science community really appreciates that. So in the short term, certainly that will supplement funding for research. I worry a little bit about the long term. I mean, will the government say, that has been our primary source of funding, well, these other guys are taking care of it. We can spend our federal dollars on something else instead. How do we guard against that?
I don't know how we guard against that. I mean, that's a question of convincing people in government that this is important over time. Again, it's a general communications issue. Sometimes when you ask scientific groups to give you information to convince people and create an argument and make a point, they don't know what to show you. I was making a point in my talk about clear communications and groups like Climate Central that are trying to engage different skill sets to actually tell the story. Scientists don't always tell the story very well, and I think when we start to tell it better, and we really can, we may see a different attitude out of people in our government.
And AGU is investing a lot of thought on that issue as well. How do we better tell our story? Thank you.
I just want to add to that. So yes, storytelling is important, but if I come to government, one of the arguments that I'm trying to make is that governments, if they think of those 4 principles and market failure, one of the roles of government is to make those platforms for participation and to create assets that are opened up so other people can get at it. And I look at the whole opendata.gov, which the US government was the first one to do it, and everyone else rapidly followed, which was to look at assets that they had and make them available to others. And I would say, I would also argue that like the Wi-Fi spectrum is an open asset. And so we, all of us in this room, need to keep reminding government and pounding on them that their job is economic enablement, and they do that by making these platforms for participation and making resources that are opened so that more people can share them, and that when they sell off pieces of spectrum to one group, it's a very inefficient use of asset because those things aren't well used. So we can look at the internet, it's the same thing. Yes?
As a climate and carbon cycle scientist, I continue to be just amazed by the anti-science backlash with the public, and even worse with our political leaders. And I wonder if you have any advice for us as scientists of how to do a better job of communicating our science so that it does a better job of informing these people.
I was having an email exchange with John Holdren on this topic many years ago, and I think one of the problems with scientists is that you're scientists and you're doing your jobs, and so I was yelling at him by email nicely that you know, we think of all the climate scientists as, you know, the probability of this is X, and the other probability is that there's this constant couching in problematic and probabilistic and statistical ways. You can't communicate on that basis. That is not speaking to people. And so this part that I presented here, this is the highest likelihood, as in the 67%, this is what we think is going to happen, the highest likelihood outcome. And I didn't parse down, yeah, there's a chance there's going to be this and this and this, because that completely undercuts what it is you do. So I do feel that there's this giant challenge for scientists, that you know that you want to present the entire grayness and the entire reality of it. But we are living in an age of sound bites. And so I deeply share your angst about it. And I can just, so maybe you have to work closer with people who can condense where you feel like you can't. But you guys are really so much the cutting edge of what's happening. And a slide that I didn't go to because I didn't have enough time was how you guys really need to speak up more and more. That, I mean, everyone needs to speak up, but you have your own experience base and your own, your highest and best use, and each one of us has to work to our own highest and best use. And you're going to be able to say things that I can never say. So you have a really important role to play.
Well, thank you very much. I think we're going to close there, and let's give a hand to Robin and Wendy. Thank you so much.